Okay, 4.1. Chapter 4.1 is on solving systems of linear equations by graphing. So we're going to work a couple example problems and let's get started. So number 4, here's number 4. It says x plus y. Here's my system. It says x plus y equals 2 and x minus y equals 6. Well, they told me to solve this by graphing. And what does it mean to solve a system of equations? It means your answer, your solution, if I plug it into the first equation, it works. If I plug it into the second equation, it also works. The solution has to work for both equations. So they say solve by graphing. So let's graph this. So I'm going to graph, I'm going to do the first equation first. So I have x plus y equals 2. And I'm going to graph this by using the x and y intercepts. So let's do the x-intercept first. So x-intercept is where y equals 0, so I just end up with x equals 2. So my point is 2, 0, because remember it's an ordered pair, x, y. So let's put on that point 2, 0. There he is. Awesome. Now let's do the y-intercept. And the y-intercept is where x equals 0, so I can end up with y equals 2, or the point 0, 2. And there he is. Connect your points. A little messy, but that's your line. That's the line equation. Sorry, let's start over. That's the graph of the first equation. Now let's try the second one. The second one is x minus y equals 6. So we have x minus y equals 6. Again, we're going to use the x and y intercepts. So the x-intercept is where y equals 0, so I end up with x equals 6, or the point 6, 0. Where's that point at? Let's put it right there. Good. The y-intercept is where x equals 0, so I end up with negative y equals 6. Now, unlike before, I'm not done because there's a negative sign in front of my y, so I need to divide by negative 1. And I really end up with y equals negative 6, or the point 0, negative 6. So there he is. Connect these points. Let's see if I can do it. Almost. There we go. Awesome. And let me quickly verify. Yep. So I've graphed in red the first equation, and I graphed in blue the second equation. Where they intersect is where the solution is. So let's get a different color in here. Let's go for green. So where do they intersect? They intersect right here. So the solution, or solutions, depending on how many, is where they, as in the equations, intersect. I hope I spelled that right. Intersect. Alright, so if I kind of messed up here, but it's supposed to be on 4, negative 2. So the solution to this system is 4, negative 2. We can quickly check that. Put in 4 for x and negative 2 for y. So 4 minus 2 is what? 2. What about here? 4 minus negative 2. 4 minus negative 2. And what is that? It's 6. So it works. So when solving systems of equations by graphing, the first thing you want to do is graph the first equation, graph the second equation, and find out where do they intersect. And that's your solution. Let us try one more. Let's look at number 7. So let's look at number 7. So here's number 7. And it says y equals 1/2 x and y equals 2x minus 3. This is my system, and I'm going to solve it by graphing. So if you will allow me, of course you will, I'm actually going to erase just this piece and the graph, of course, so I can use it again. Okay. Let me write this answer over here. The answer was 4, -2. All right. So we're going to graph the first equation. If you notice, it's in y-intercept form, so I'm going to graph it using the slope. I'm sorry, that's a lie. Let's take a step back. You notice it's in slope-intercept form, which means I'm going to graph it using the slope and the y-intercept. So equation number 1. So here's equation number 1. We have y equals 1/2 x. The slope is a half, and the y-intercept is not there, so it's 0. So let's graph this. When you're graphing with the slope-intercept form, you start with the y-intercept, which is 0. It's 0, and then from there, we're going to use the slope. So I have a point at 0, and then using that point, using the point and slope, I'm going to find another point. Slope says 1/2, so the 1 tells me to go up 1 tick mark, and 2 tells me to go to the right 2, and there's another point. Good. Connect them the best you can. And that's the line of equation 1. Here's equation number 2. And we have y equals 2x minus 3. So again, it's in slope-intercept form. So I'm just going to graph it using the slope and the y-intercept. The slope for this one is 2/1, and the y-intercept is -3. So where is -3 at? It's right here. So I have a point right there. And then the slope says go up 2, so 1, 2, and to the right 1. And then connect to the best you can. I believe this one's off a little bit, but it's fine, it's fine, it's fine. Which means I need to fix it. So give me a second while I fix my graph. I need a straight edge, that's what I need. So let's see here. This guy, I think that's right, almost. What do you think? A little off, but it's okay. It's okay. Awesome. So, first step was to graph the first equation. And the second step is to graph the second equation. You know what? I know I'm being a little picky and tedious here, but I'm going to have to graph these two again. It's me, it's not you. So let's see here. Let's graph the first one. So it has a y-intercept of 0, and slope says 1, go up 1, and to the right 2. And then let's connect these. Let's be a little cleaner. Okay. Now the second one has a y-intercept of -3. So -3. And the slope says go up 2, 1, 2, and right 1. Good. And connect. And connect. Good. So now let's go back to step 3. Well, I graph them. I graph each equation. That's step 1 and step 2. Step 3 is, all right, where do they intersect at? And I had to do my graph over again just to make sure that I had the right place. Awesome. So they intersect here, which means your solution's there. So you have a solution at the point 2, 1. It doesn't look like it, but if I had a straight edge, it would be at 2, 1. And of course, we can check it. If I plug in 2 for x, I get 1/2 times 2, which is what? 1. So that works. If I plug in 2 for x, I get 2 times 2 minus 3, which is what? 1. So it also works. So the solution is 2, 1. And that's how you solve systems of equations by graphing. Graph each equation and then find out where they intersect.